Okay everyone, welcome back. This is the ninth video in the series and this is integration of exponential functions. We're going to look at two different types, functions with base e and bases other than e. So let's get started with the integration rules for exponential functions. Let u be a differentiable function of x, and we have our first rule, which is simply the antiderivative of e to the x dx is simply e to the x plus c. Okay, so this rule applies simply if the exponent is x. But what happens if the exponent is not x? Then we have this thing, rule number 2, which is e to the u du. And that becomes e to the u plus c, my constant. However, what we need to understand, and this is very similar to what we did in logarithms, is that the du part is really u prime. So if it fits the pattern of e to the u times u prime, du, then we simply take the antiderivative of e to the u plus my constant. If this doesn't make sense yet, you'll see why soon enough. I'll give a couple examples and it should be fairly clear. So let's start off with an example. And what we're going to do is we're going to break it down according to the second rule. So we have the antiderivative of e to the negative x to the fourth times negative 4x cubed dx. Okay, what I need you to understand is this. This first part is simply e to the u, and the second part is the derivative of u, which is negative 4x cubed dx. Well, negative 4x cubed dx is my du. So therefore, all I really need to do is simply find the derivative or the antiderivative of e to the negative x to the fourth. This is in the proper form with no modification to the question that is required. Now, what do I mean by that? Well, like we did in logarithms in the last video, where we saw that there was something missing with u prime, here there's nothing missing. The derivative of negative x to the fourth is simply negative 4x cubed. So it fits the pattern, nothing to do, simply follow the rule that I gave you above. And let me show you why this is the case. If we let u equal to negative x to the fourth, and we take the derivative, we get du dx equal to negative 4x cubed. If I cross multiply, I get du is negative 4x cubed dx. So as you see, it fits the pattern, so all I need to do is simply take the antiderivative of that first part, which is simply e to the u. So if it fits this pattern, then all I need to do is simply follow rule number 2, which is e to the u plus c. And looking at what we did previously, e to the negative x to the fourth times negative 4x cubed dx, the derivative of negative x to the fourth is negative 4x cubed, so therefore it fits the pattern, and therefore all I need to do is simply write down e to the u plus my constant c. So it's a very, very simple process. We just have to understand that u prime, if there's nothing missing, then there's no modification required. But if there is something missing, then we need to modify it like we did in the previous videos with logarithms. And I'll show you a couple of examples in this video. So let's take a look at the second example. We have the integral of e to the 1 minus 3x dx. We're looking for the antiderivative. Now, we have to ask ourselves, is there something missing? Is a modification required? Okay, and in this particular case, yes, a modification is required. Now, you could spend, 2-3 minutes trying to figure out exactly what that modification is, or get into the habit of simply working it out. If there's nothing missing, great, and if there's something missing, well, you already have the work for it. So, we're going to let u equal to 1 minus 3x. We're going to take the derivative, du over dx equal to negative 3. We're going to solve for du and end up with negative 3 dx. Now, I only have a dx, so therefore I need to solve for dx, and I end up with negative du over 3. Great. Write everything in terms of u. I know that negative du over 3 is my dx part, and of course I have e to the u. Fantastic. I have my constant, which is negative 1/3, which I factored out, and now I end up with e to the u du. Follow the rule, and I end up with negative 3 e to the u plus c. Since u is 1 minus 3x, simply replace u with 1 minus 3x, and there's my antiderivative. Okay, the third example, you're going to see the connection between the logarithmic rules that we learned in the last video and the bases or the exponential functions with base e. So, once again, it's in rational form. If it's rational form, the first thing I should do is verify if I have the form u prime over u du. So if that's the case, then I know that it's simply ln of the absolute value of u plus c. Okay, now we're simply going to let u equal to 1 plus e to the 2x. We're going to take the derivative and end up with du over dx equal to 2 times e to the 2x. We're going to cross multiply. Du is equal to 2 times e to the 2x dx. And what I want you to notice is that all I have is e to the 2x dx. So I need to divide both sides by 2 and end up with du over 2 is equal to e to the 2x dx. Great. There was a modification that's required. I'm going to write everything in terms of u. According to the rule that we learned in the last video, 1 over u du is simply the ln of the absolute value of u. And since u is equal to 1 plus e to the 2x, there we go, the antiderivative. Okay, so now we're going to evaluate a definite integral. So let's take a look at this example. I have this integral x squared times e to the x cubed over 2 dx, and we're going to evaluate from negative 2 to 0. Okay, the first thing I'm going to do is I'm going to rewrite it. Now, e to the u times du, or e to the u times u prime. And if I look closely, I can see that maybe there might be something missing. So what I'm going to do is simply let u equal to x cubed over 2. Find the derivative, du dx equal to 3 halves x squared. Cross multiply. And now what I notice is that I only have x squared dx. But here I have 3 halves x squared dx. So I'm going to solve for x squared dx. And therefore I end up with 2/3 du is equal to x squared dx. Fantastic. I'm going to write everything in terms of u. Now I have 2/3 times the integral eu du. So far so good. Now here's the problem. I need to verify if I'm going to evaluate with negative 2 and 0, or I'm going to have to change those values. So going back to the last video, we have a choice to make at this point. We either integrate by replacing u with x and keep the same upper and lower limits, or we integrate with respect to u, however I need to change my limits. So let's do both of them just to show you. So in this particular case, I decided to simply replace u with x. And now we have 2/3 times e to the x cubed over 2, and we kept the same limits, which is from negative 2 to 0. So when I do f of b minus f of a, I end up with 2/3 times 1 minus e to the negative 4. Okay, so because I decided to replace u with x, I kept my lower and upper limits, and I evaluated using those. However, if I decide to evaluate using u, then I need to change my lower and upper limits. So negative 2 becomes negative 4, and 0 remains 0. So when I perform, or when I use the fundamental theorem of calculus, f of b minus f of a, I end up with the exact same answer. So when evaluating definite integrals, if you're going to evaluate using u, then make sure you change your upper and lower limits. But if you're going to evaluate and replace u with x, then you can keep the same limits. So let's take a look at the integration rule for bases other than e. Okay, there's only one rule we're going to use, and it's this one. The integral of a to the u du. Now remember, a to the u du simply means that there's no modification required if u prime represents du. And if there's something missing, then we need to modify. So the rule is simply 1 over ln of a times a to the u plus c. So once again, this is the only rule we'll use for bases other than e. Let's take a look at some examples. We have 5 to the negative x dx. Okay, so we're going to let u equal to negative x. We're going to find the derivative, du dx equal to negative 1. We're going to cross multiply. Du is equal to negative dx, but I only have dx, so there's something missing. So I'm going to solve for dx and end up with negative du. Since negative du is like negative 1, factor out the negative 1, and now replace everything, or rewrite everything in terms of u. Final answer, negative 1 over the ln of 5 times 5 u plus c. U was negative x. Simply replace u with negative x, and there we go. There's my antiderivative. So for the second example, we have 7 to the 3 minus x all squared times 3 minus x dx. Okay, So looking at this, it seems like there's something missing. So I'm not going to break my head. All I'm simply going to do is simply work it out and see what happens. So let u equal to 3 minus x all squared. Find a derivative, like we did previously. We're going to cross multiply. And what I want you to notice is that there's an extra negative 2 that's being multiplied to the 3 minus x. So because all I have is 3 minus x dx, I'm going to divide both sides by negative 2. Now remember that negative du over 2 is really negative a half times du. So I'm simply going to factor out the constant, and I'm going to write everything in terms of u. Great. Now follow the rule. Negative 1 half times 1 over ln 7 times 7 to the u. Because we've replaced u with 3 minus x all squared, simply replace again, and there's my antiderivative. Now the third example is a little bit different. This is where we start to make the connection between logarithmic integration and functions with, with bases other than e. It's a little bit tough to say. Okay, so the first thing you have to realize is that it's in rational form. So if it's rational form, the first thing that should come to mind is, okay, hold on, it might be logarithmic. So how do I verify? Remember that the logarithmic integration has to do with u prime over u. So let's get started. We're going to let u equal to 3 to the 2x. We're going to find a derivative. We're going to cross multiply. And we're going to solve for 3 to the 2x dx because that's all I have in the question. Now remember that du over 2 times ln of 3 is simply a constant. It's a number. So we're going to factor out that number and rewrite everything in terms of u. Now, the question here is, I have 1 over 1 plus u. Is that u prime over u? And yes, it is. So now I can use the logarithmic integration. And because u is equal to 3 to the 2x, simply replace u with 3 to the 2x. And there's my antiderivative. And as always, practice, practice, practice. The more you practice, the better you'll get at these concepts. I guess the most important thing I have to say is don't forget to verify if it fits the pattern. If it does not fit the pattern, then that means there's something missing, something needs to be modified. Just go through those steps, letting u equal to something, finding the derivative, and solve for what you're given. And it'll be much easier that way. So good luck, enjoy, and wait till the next video comes.